I will quickly run through the introduction to this workshop and why we want to have your opinions and thoughts from this. So this is a VALESOR workshop. It's funded by the European Union, and VALESOR stands for Valuation of Environmental Stressors. And we will now demonstrate and test the VALESOR tool and discuss how well it works for the needs that decision makers might have. So why are we here? Cost-benefit analysis is important for environmental policy, as we all know by now. It's consistently used, it's not consistently used for many decisions or many environmental policies. And there's also a lack of data on the actual benefits of a cleaner environment and a reduced pollution, better air quality, and reduced chemical pollution. In our community, we are used to assessing benefits with the alpha risk pool model, and it's always a bit difficult for non-model users to understand and accept results from this. And through this process, we hope that we can have a simplified version of the VALESOR tool, which is based on the full-scale model developed by Mike Holland, and it will be presented. So here today we will introduce the tool, we will test the tool, and we will also discuss the tool and whether you consider it usable or not, whether you think it can be usable or how it can be improved. Objectives of VALESOR of concern for this particular workshop relates to the development of this extended model, the ARP version 2. A more expanded version than what we used for air quality policies in 2018-19, and also to develop an online VALESOR tool. The picture you see here is just an idea of a picture of how a website could have looked when we submitted the application. What you will finally see is not the same. Again, VALESOR is part of the Meteor cluster funded by Horizon Europe. And as you might have heard, if you were not included, there are many in our Meteor cluster together here with us today, and we are very grateful for that. So thank you so much for this. Stakeholder input, why? Well, basically, none of us is interested in developing an online tool that is never used after the project dies, projects don't die, they end. And there's also a risk that the usability of the model can be misunderstood by those who develop the model or those who are super users, such as ourselves in the VALESOR program, because there's also a tendency that if you use a model or a tool regularly, many hours per week, then you know all the shortcuts, you know all the kinks. But if you are only supposed to jump into the model every now and then, there might be other problems that occur. So therefore, external stakeholders are needed to help us understand if the model answers the questions it should answer and if it is usable. But also, of course, it's interesting for us to share information about the VALESOR tool. So today you will hear from me, as you've already done, and you will hear from Mike Holland about the ARP tool, and Katarina Jaramenka will lead the presentation of the VALESOR tool, after which we will let you work around with the model and discuss the model. So the program, with this quick intro, we are not too delayed. But now you heard about the VALESOR project, followed by the alpha risk pool model that will be presented by Mike Holland. And Katarina will present the VALESOR tool, and then we will have at least 25 minutes for testing and 15 minutes for discussion before we wrap up for the day. And I will try to moderate the meeting as it goes through. So with this, I am done with my part of the agenda, and I can hand over to you, Mike.
Okay, thanks, Stefan. Let me share my screen. So I'm going to give you a bit of information about the history and recent updates to the alpha risk pool, or ARP model for short. ARP, its latest version of a model that we developed back in the 1990s. The alpha part of alpha risk pool stands for atmospheric long-range pollutant health assessment model. That was developed by me and others at AEA Technology, which is a consultancy that has been changed hands many times, and I've even lost track of who they've recently been bought by. But it was originally developed to support what was then termed the EU's acidification strategy, so focused on sulfur and nitrogen deposition. It was a bit of a surprise, I think, when we originally produced this, because the acidification strategy didn't actually take account of health impacts in its early stages, and we came up with with very big numbers for health impacts of air pollutants, and they were subsequently taken very seriously on board in all the air pollution work, to the extent now that you don't hear very much about air pollutant effects on ecosystems outside of the scientific circles and outside of the UNECE convention. It was also used at that time for proposals for the second sulfur protocol to the UNECE Air Convention, which subsequently became the multi-pollutant, multi-effect protocol proposal, and then the Gothenburg proposal. The development was informed by research under the ECUS fuel cycle study that became the Externi study, and I think that's a particularly well-known bit of research done by funded by the European Commission back in the 1990s. Alpha Rispol, the Rispol part comes from the Rispol model developed by Joseph Spadaro, following work for the International Atomic Energy Agency on the Sympax model. Joe separately went and developed his own model, Rispol. That has informed some of the development of the ARP model. ARP has been used for air pollution assessments many times over the years, from the late 1990s through the early 2000s and the CAFE program in the early 2010s. We were working on the marine emission control areas in mid-2010s. We developed a global version for the OECD Circle project. In more recent times, we've used it for work on the Clean Air Outlooks 1 to 4, 4 being published earlier this year, and all the legislation that links into them. National versions have also been developed for UK, Sweden and France, and the model's been regularly updated as new research provides additional data. I think it's useful to note there that the updates over the years have led to a gradual increase in the estimated value of air pollution damage across Europe on a sort of per unit exposure basis. So the early version we could regard as being rather conservative. I mean, it reflected the state of science at the time, but as time has gone on, we've found that air pollution is more harmful than we were originally estimating. Model availability, previously only via direct contact with me, basically, and under VALESOR we are developing the web version that Katerina will discuss in more detail a bit later on. Inputs to the model, annual mean population weighted exposure data for PM2.5, NO2 and ozone. PM2.5 there includes the secondary reaction products such as ammonium sulfate and ammonium nitrate aerosols. No provision is made in the model for pollutant dispersion and chemistry modelling. Joe Spadaro's Rispol model does contain some facility for that, but within the ARP model, we designed the tool to use outputs from sophisticated pollutant dispersion chemistry models such as EMEP or detailed local dispersion modelling that would account for local topography, a level of detail that we couldn't hope to recreate within our own model without basically reinventing wheels. So by importing the pollution data, we avoid a lack of consistency of the pollutant data with accepted models, basically by using the outputs of those. models. So those are the basic inputs. Information contained in the model covers population data at the national level, from 2000 to 2100, data on incidents of health conditions, which response functions are included, the response functions themselves, valuation data for each quantified health impact, and various conversion factors that are needed for the quantification. So that's really at the heart of the model, and that enables us to provide the following outputs: annual undiscounted estimates of health impacts as cases, life years lost, hospital admissions, etc., and their economic equivalent, and aggregated estimates of overall economic impacts. The full version of the model includes sensitivity analysis on mortality valuation using both value of statistical life and value of life years approaches. It also investigates overlap in the PM and NO2 functions. There's risk there of double counting, so we explicitly account for that in the full version of the model, and various other sensitivity analyses as different studies have required. The results can be provided at any desired scale. Most of the work I've done with it is either at the EU or UNECE level. Some of it's at the national level, and occasionally I've used it at the subnational level as well. Needs a little bit of adaptation for me to use it in that way, but it is still easily possible based on the data contained within the model. Post-processing, so what the model doesn't do is doesn't factor in discounting. It doesn't factor in a more detailed uncertainty assessment, which is sometimes required. It doesn't include the damage costs for impacts on materials, crops, forests, and natural ecosystems. We have got estimates of those, so they can be added in afterwards. And then using results in CBA. So the results from the alpha risk poll model are feeding into that kind of analysis, building up an overall estimate of the damage that can be used in cost benefit assessments. For the VALESOR work, we've got the VALESOR work has involved a full update of the model reflecting the latest science, developing a web version for wider availability, as Katerina will describe. The objectives, inputs, etc. of the model largely remain as in the earlier versions, as I've just described, and the project is ending in December this year, so not very far off at all. Specific updates under VALESOR: population data reflects latest Eurostat and UN data for the non-EU countries. The incidence data has been extracted from the Global Burden of Disease Initiative for specific age groups, as reflected in the response functions. The health impacts that we include in the assessment are taken from literature reviews. Recommendations have been made for a set of effects for core and sensitivity quantification. Drawing on the HRAPI2 and EMAPEC studies from WHO in particular, which we've also used to update the response functions. The valuation data we're using has been thoroughly reviewed and updated. That is still an ongoing activity. We've taken more care now to separate costs to direct, indirect, and intangibles, as the OECD health systems accounting guidance describes them. So direct Costs are effects on healthcare systems, indirect costs are effects on productivity, and intangibles are effects on utility and welfare. And for most of the effects that we look at, it's the intangibles, the so-called intangibles, that are the most important economic element. Further work is going to be integrated as it's finalised, and that will include conclusions on mortality valuation from an OECD project that we understand to be published in the next, hopefully in the next couple of months. So hopefully that will give us time to include reflections on that in the work on VALESOR. And also there will be some original valuation estimates coming out of the VALESOR study. One last thing I want to emphasize is that the version of the model that we're talking about today is very much focused on air pollutants, and we are working on a separate tool for chemicals, which will have a slightly different form to what's being discussed today, but it will be an overall sort of similar structure. And